Hello, everybody. In this lesson, we will learn the Y voltage reduced start circuit. First of all, let's think about one question. The direct starting circuit is simpler. Why do machines and equipment need to be started by reducing voltage? Next, let's come to learn with questions. The voltage applied to the stator winding of the motor during startup is the rated voltage of the motor, which belongs to full voltage startup, also known as direct startup. The advantages of direct starting are the use of fewer electrical equipment, simple wiring, and minimal maintenance. But when starting directly, the starting current is relatively high, usually 4 to 7 times the rated current. In cases where the capacity of the power transformer is not large enough and the power of the motor is high, direct starting will lead to a decrease in the output voltage of the power transformer, which not only reduces the starting torque of the motor itself, but also affects the normal operation of other electrical equipment in the same power supply line. Therefore, when a larger capacity motor is started, it is necessary to use a voltage reduction starting method. Usually, it is stipulated that three-phase asynchronous motors with a power capacity of over 180 kVA and a motor capacity of less than 7 kilowatts can be directly started. For those that do not meet the conditions for direct starting, depressurization starting must be used. Step-down starting refers to the use of starting equipment to appropriately reduce the voltage and apply it to the stator winding of the motor for starting. After the motor starts and operates, the voltage is restored to the rated voltage for normal operation. As the current decreases with the decrease of voltage, step-down starting achieves the goal of reducing the starting current. However, as the torque of the motor is proportional to the square of the voltage, voltage reduction starting will also result in a significant decrease in the starting torque of the motor. Therefore, the depressurization start needs to be carried out under no load or light load. Common methods for voltage reduction starting include stator winding series resistance voltage reduction starting, autotransformer voltage reduction starting, Y-delta voltage reduction starting, soft starter voltage reduction starting, etc. Y reduction start control circuit as shown in the figure. The circuit consists of 3 contactors, 1 thermal relay, 1 time relay, and 2 buttons. The contactor Km is used for introducing power. The contactors KMY and Km are used for Y-shaped voltage reduction start and shaped operation, respectively. Time relay KT is used to control the Y-shaped voltage reduction start time and complete the Y-delta automatic switch. SB1 is the start button. SB2 is the stop button. Fu1 is the short circuit protection of the main circuit. Fu2 is the short circuit protection of the control circuit, and KH for overload protection. In this line, after the contactor KMY is powered on, the auxiliary normally open contact of KMY is used to activate the contactor Km. In this way, the main contact of KMY is closed under no load conditions, thus extending the service life of the contactor KMY main contact. Installation precautions. 1. The motor controlled by Y-delta voltage reduction must have a rated voltage of 6 outgoing lines equal to the line voltage of the 3-phase power supply. 2. When wiring, it is necessary to ensure the correctness of the motor's delta connection method, that is, when the main contact of the contactor is closed, it should be ensured that U1 and W2, V1, and U2, W1 and V2 of the stator winding are connected. 3. The incoming line of the contactor KME must be introduced from the end of the 3-phase stator winding. If its first end is mistakenly introduced, when KME is closed, it will cause a 3-phase power short circuit accident. 4. The external wiring of the control board must be installed in the wire channel as required, so that the wires have appropriate mechanical protection to prevent the invasion of liquids, iron filings, and dust. During training, the requirements can be appropriately reduced but must be based on conditions that ensure safety, such as using multi-core rubber wire or plastic sheet flexible wire. 5. Before powering on the calibration, it is necessary to double-check whether the melt specifications and the setting values of the time relay and thermal relay meet the requirements. 6. When conducting power on calibration, there must be a guide teacher on site for monitoring, and the calibration should be conducted independently according to the control requirements of the circuit. If a malfunction occurs, it should also be resolved by oneself. 7. Installation training should be completed within the specified quota time. At the same time, it is necessary to achieve safe operation and civilized production. That's the end of the content for this class. See you next time.